Hello guys, welcome back. So here we have a question in communication systems from GATE EC 2024. This is a very interesting question. A source transmits a symbol S taken from -404 with equal probability. So there is a source S and this will transmit either of 0, 4 or -4. Okay, and with equal probability. So all this will be having probability of 1 by 3, 1 by 3, 1 by 3. Okay. So and it is transmitting over an additive wide Gaussian noise channel. So there is a noise channel which is having wide Gaussian noise. And on the receiving side, we have the noisy signal, right? So the noisy symbol is given by R is equal to the symbol S plus W, where W is your zero mean noise with variance of 4. So your mean of W is 0 and your variance is 4. So your standard deviation is 2. And this they are saying is independent of your S. And then they have given Q of X is the error function, which is given by 1 by root of 2 pi x to infinity e power minus t square by 2 dt. And they are asking us to find the optimal symbol error probabilities. And here they have also given the options in terms of Q of X. So we have 2 by 3 Q of 2, 4 by 3 Q of 1, 2 by 3 Q of 1, and 4 by 3 Q of 2. So we need to find the error probability which is optimal in terms of Q. So here again, before starting, we'll understand few of the terms. So the first one is wide Gaussian noise. So this we already explained in the previous video. Now to come to the Gaussian noise, the distribution is actually a Gaussian. So this is your Gaussian distribution. And your probability density function P of X for this is given by 1 by the standard deviation root 2 pi e power minus half into x minus mu by sigma whole square, where mu is mean and sigma is your standard deviation. So for mu equal to 0 and sigma equal to 1, which we also call as your standard normal distribution. And if you take any point x, and if you want to find this area, so what will it be given by? So it is integral x to infinity this function. Let's say for the standard normal distribution, mu is 0 and sigma is 1. So it is 1 by root 2 pi e power minus t square by 2 into dt. Or in this case, you can also take x. So this is nothing but your, if you observe, your error function Q of X. So this is about your noise. Now let us come to our symbols. So our symbols are -4, 0 and 4. So in the amplitude domain, right, you have -4 here, 0 here and 4 here. So if there is no noise at the receiver, we would only observe these three symbols, right? And each of them will have probability of 1 by 3 because they are equally probable. So now what is happening on top of this, you also have your noise. Then how will the distribution change? So if you only have your -4 and you have noise on it, your distribution will become like this. So the Gaussian the shape will remain same. So here only your mu will change to -4. So similarly, your at 0, you will again have the same distribution. Your mu is again still 0, remaining at 0. And at 4, your Gaussian will remain same, shape will remain same. Your distribution will have a mean of 4 here. Now this is how the three distributions will look like, and each of these points will again have 1/3 probability on top of the Gaussian distribution. So in this place, if this point is A, here each of them will have A by 3, A by 3, A by 3 and so on. Okay. So now if you look at your receiver data with noise, you will observe all these amplitudes. And they will be having probability given by this Bell function, this kind of function. Okay. So now we need to detect them and we need to do it optimally. So here you see, you need to find optimal error probability. So to detect them optimally, intuitively also it is easy. You just have to take the midpoints. For 0 and -4, you take at -2 and here you take at 2. So if your symbol, whatever you receive, if it is greater than -2 or if it is less than -2, I will say my symbol is -4. And if it is between -2 and 2, I'll say my symbol is 0. And if it is greater than 2, I'll say my symbol is 4. So this will happen if the x's lie between these, then it is my correct symbol. But now I need to find the error. So let us observe each of these symbols separately. So I'll first take for the symbol s equal to -4. So how is this distribution? So at -4 we have So this is a Gaussian distribution with mu of -4 and sigma what they have given. So the white Gaussian, the sigma was 2. So this is going to be equal to 2. And we said for this the optimal detection point is -2. So for this symbol, if I said for my x greater than -2 or x less than -2, if I detect -4, it is the correct symbol. So when will I make an error? When my x is greater than -2, then I will make an error, right? Because then it will fall in other zones, right? Up to 2, it is going to fall in 0 zone, and here it is going to fall in 4 zone. So I want to calculate this area. So this will give my error, right? Error I'll make. So the probability of error I'll make is P of x greater than -2. So this I have to write in terms of Q. So for that what I'll do, I'll just convert this into a standard normal distribution. So now this is having mu of -4 and sigma of 2. So if first I will take out the mean. So for that I'll add +4. So x plus 4 is going to have 0 mean, right? Because I'm shifting this to origin now. So then what happens to my right hand side? -2 plus 4 will become 2. Then I have to make it a unit variance, right? So for that I have to divide by your standard deviation. So P of x plus 4 by 2 greater than 2 by 2 will become 1. So this is my standard normal distribution. So now I'll replace this with n greater than 1. So let me call n as this function, and n is also going to be a random variable, and it is going to have a Gaussian distribution. So by adding so if you take a Gaussian distribution, if you add any constant to it, your mean is going to shift by that much. So x plus a, your mean will shift by that much. And if you divide by whatever variable, that will change your standard deviation. So your standard deviation will move by sigma by b. Okay, so coming back here, so this greater than 1 is nothing but in your standard normal distribution, this place is going to be 1. So this is the area. So this is nothing but q of 1, right? So this is equal to q of 1. So for -4 we have found. Similarly, we have to find for 0 and 4. So let us quickly do that. The same process only. So now second s equal to 0. So x equal to 0, what did we have? We had it around 0, and we said our range is from -2 to 2. This is where we are making the correct decision. So our error will be made if we consider these data points. So what will be my probability of this? So this is P of x less than -2 and P of x greater than 2. So this is independent, right? So I can just separate it out. So x less than -2 plus P of x greater than 2. And your x itself has 0 mean. So each of this can be written as P of x plus 0 by, and the variance, the sigma is 2. So I'll divide by 2. So -2 by 2 will become -1 plus P of x plus 0 by 2 is less than 1. So this is again equivalent to my standard normal distribution. So this is P of n less than -1 plus P of n greater than 1. So this we said is Q of 1. So what is the P of n less than -1? So if you observe the standard normal distribution or any Gaussian distribution, it is going to be symmetric about your origin, right? The standard normal distribution. So from -x to -infinity also, it is same as x to infinity. So this is also equal to Q of 1. So I'll get Q of 1 plus Q of 1, which is equal to 2Q of 1. Similarly, we should also do it for S of 4. So if you again observe, you needn't calculate it. Your S of -4 was, for x greater than -2, it was having error. So for your x of 4, it will be the other way around. So it will be this area which will make error. So your x should be less than 2 for error. So this again will be similar to whatever you calculated for your -4 case, which is coming to be Q of 1. So this is also Q of 1. So now you have 3 probabilities, right? Error probabilities. Your P1, P2, which is 2Q of 1, and P3, which is again Q of 1. So now each of the symbols can be 1/3 probability. So what is your total error probability? It is 1/3 of P1 plus P2 plus P3. So which is equal to 1/3 of Q of 1 plus 2Q of 1 plus Q of 1. So this is again equal to 4/3 Q of 1. So this is your error probability for the optimal case. Again, I'm not going into the theory of the choice of optimal point, but even intuitively you can see it only makes sense to make it at the midpoint. So this you have to remember. So our answer here is 4/3 Q of 1, which is option B.